Here's problem 13. An elementary school teacher has a collection of mathematics review questions, including 10 addition, 8 subtraction, and 15 multiplication. All right, so if we have 10 addition, 8 subtraction, 15 multiplication, we have a total of 33 questions, don't we? A computer randomly selects problems for a student. Find the probability that the first problem selected is an addition or subtraction problem. So we want, what's the probability that we get an addition or a subtraction problem for that first problem that the computer would select? Well, the computer's just selecting one problem. If there are 33 total problems, then the total number of outcomes would be 33. There are 33 different ways that computer could select the first problem. How many are addition? 10. How many are subtraction? 8. Is there any overlap between those? No. A problem's an addition problem or a subtraction problem. It can't be both. Those events, we could say, are mutually exclusive. Being an addition problem, being a subtraction problem are mutually exclusive. So what's the probability that that first question would be an addition or a subtraction? Would be 18 out of 33, which 18 out of 33 gives us roughly 0.545. Or almost, 54.5% of the time we would expect to get an addition or a subtraction problem? And that makes sense, doesn't it? That's a little over half the number of problems we have. So wouldn't you expect a little over half the time that you'd get one or the other of those problems with your selection by the computer? Okay. Well, let's see what the other part of that problem says. It says, find the probability that the first two are subtraction or multiplication problems. Okay, so now the computer is selecting two problems for us. Now the computer is selecting two. So we want to know, what's the probability that we would get, what was it again here, a subtraction or multiplication problem? That the first two, that we would get 2 subtraction or 2 multiplication. So now the computer is choosing two problems for us. Well, that would be then a combination, wouldn't it? A combination of 33 problems taken 2 at a time. And we want to know what's the probability that we got 2 subtraction or 2 multiplication. So we would need to count the number of ways to get 2 subtraction problems, add to that the number of ways to get 2 multiplication problems, and those would be the total number of successes we could have. So 2 subtractions, that would be a combination of 8 taken 2 at a time. 2 multiplications would be a combination of 15 taken 2 at a time. So that's going to be, what, permutation of 8 taken 2 at a time over 2 factorial, plus permutation of 15 taken 2 at a time over 2 factorial. All of that over permutation of 33 taken 2 at a time over 2 factorial. And once again, all of these 2 factorials are going to cancel each other out. So that would give us 8 times 6 times 15 times 14 over 33 times 32. And all of those numbers, let's see, what does that come down to? It comes down to 133 over 528. 133 over 528, which gives us 0.252. So the probability that we would get 2 subtraction or 2 multiplication problems is 252 thousandths. So roughly what? 1/4 of the time we would expect that to happen when the computer generates 2 problems for us to solve.